Hello and welcome, my name is Nasty. In today's video we're going to talk about how to benchmark in Factorio. Before we get into the actual video, I want to actually just give a disclaimer and some food for thought on what I think about benchmarking. So, benchmarking is extremely useful for you to compare one design versus another. Today we're testing different inserter control methods and I'm going to be using that as an example. Now, when you're going to see some results that are going to be in this video, I'm going to scrutinize it. I'm going to go and try to validate the hypothesis that I have. And I'm going to also go and say, hey, why is this benchmark better? I wouldn't think this is better. Let me figure out if I had a bad problem with my testing scenario, etc. Those are really important if you're testing anything in general. You always need to be curious about, were you correct in setting up a good test benchmark? And did you do that correctly? And always not trust what you're seeing until you are absolutely confident that everything is exactly correct. So attention to detail really matters. Another thing is just because you wind up seeing, let's say, a 20% improvement from one benchmark versus another, like you'll see a lot in a lot of the designs that I do that I wind up getting, okay, this was 10% better, this was 15% better than the last design. Great. That is anecdotally useful to compare that this design is objectively more UPS efficient than the last one. However, because you wind up seeing 10% improvement, that doesn't mean you're actually going to see that in the real game. The real reason for that is that you're going to have very different setups once your game is under full load. So, for example, I run a 7800X3D that has a 3D cache that is being built into it. Once your game exceeds the amount of cache memory that is held, it has to go into RAM. Now, your timings and some of the percent improvements you saw in an isolated environment might be now very different because they're not hitting that same cache. So that just cache misses in general, where the cache is stored is going to change once you get into real world. So take that with a grain of salt and just remember that as we get into benchmarking. For this video, what I'm going to be walking you through today is 4 different kinds of inserter control methods. One where there's effectively staggered in the direction of travel. So every 8 ticks, they are enabled for 4 ticks and they're offset one at a time. The other one is going against the direction of travel. And then the other one is just every 240 ticks, it just grabs items off the belt once it completely stops. And the other one here is a little bit different, where we were experimenting this week with grabbing items at 1 tick at a time. So just 1 tick every 60 ticks, it will be enabled. So I've set these up with some Nixie tubes just so we can see that the throughput is the same. One of the first things that you wind up doing a lot is having this map editor open. The main reason is so that you can go and quickly speed through things, so that you can simulate things that you wouldn't see in a real game for hundreds and hundreds of hours, so that you can really test that your design is fully in a working condition. So in this case, I'm just making sure that the counts are all the same so that the throughput is the same, which we can see here that eventually they all line up. Cool, so we're going to use this as our example today, and I'm going to walk you through some of the tools that I use here next. So I recommend a couple mods to when you're benchmarking. Now, you don't need any of these to actually do it. You can just use the default ones built into the editor. I personally like them, so I'm going to advocate for them. So there's the editor extensions mod that's made by Rayguard, one of the developers from Factorio. This is a really nice extension of a lot of the just editor settings that you have to have inputs like infinite belts and being able to supply materials so that you can test things out. So I use this for a lot of the extra tools that come in from them, and I find it really useful. The other one that I wind up using is Region Cloner. This allows you to hover over a region, like let's say a steel smelter, and you can copy it for X number of times. So as many times, 100 times, 200 times, and that's so that you can create higher load on it. So those are the 2 that I highly recommend to use when you're setting up benchmark files. So first, how do you go and create one? So the way to go and create one would be here. You can go into single player, you can go to new game. And what I like to do is I just like to use the one that's already just by default winds up being created here. So the editor extension / testing one, because this already gives you a pretty good, decent blueprint and has already sets you up for having like cheat mode enabled so that you have everything and also time is frozen at noon and all the technology is already researched from the beginning. So it gets you into a good state. If you're testing something for earlier game designs, you may want to just go ahead and go into a sandbox mode, which is right here. And then you can just go and use that, but you have to make a couple extra settings. This changes most things, so it turns everything up to a clean workspace. So let's go ahead and just open that up. Okay, so we've created this test world here, this scenario that comes with editor extensions. And what you wind up doing is once you load into the game, you can see that you can move around. There's a couple other changes you're going to want to make to the map. So the first thing that I would recommend is you go and type in /editor into the console. And once you do that, that's going to give you access now to the editor view. You'll notice you have no more character anymore, and now you can freely move around, but you also have this map editor panel that shows up. And we're going to utilize that here next. Additionally, you also have some testing tools that are built into it as well. So one of the ones that I use most often is an infinity loader. And the reason for that is that I can just go in here, select the filters that I want, and I can pick any material that I want, and then grab a belt and bring it in. So this way you can simulate any kind of input that you want, any quality that you want. You see a lot of times that I'm doing this for U2, for example, and then you can have the items coming in on the belt. So this allows you to go and build a design and then just feed it with the things that you want to feed it into. Cool, so that's a little bit about editor extensions. So what I wind up doing usually when I go into this mode, there's a couple things that I immediately turn off. So I go to the surface settings and I will go to the edit the map generation settings. I go to advanced and I turn off pollution. I turn off pollution because it adds a bunch of extra overhead. And since the tiles here in the editor extensions world, these are all lab tiles. So you can by default generate new chunks with lab tiles. That's this surface that's here. So this has no pollution absorption effects. So effectively your game will have a lot more background noise if you just allow the pollution cloud to spread, especially if you're testing something that's very pollution heavy. So that's the second thing that I wind up turning off. And then otherwise from then on, I just wind up having the time menu built in, and I just wind up going and basically using this to control how fast the game is running. And you can see that also by the UPS number here going up whenever I'm running at a faster number. This is a game that has almost nothing in it. The next thing that I would also recommend for you to do, just so you can get more statistics and understanding of like what you're working in an editor here, you can press F4 and let's go to the debug menu. And I'm going to press F5 to show some extra characteristics. So there's two settings that I really like to use. I like to show time usage so that I get overall statistics. There's also the showing the entity time usage. If you just have this disabled, you'll see the entities that are in the game. So there's currently a radar, and you're also seeing how much in milliseconds they're using on average, and then the minimum and maximum that they have. So within like a cycle that's there. So those are things that I like to use, usually use time usage, and I put it on the debug menu, and also just, I always show you FPS because that's a useful metric for me. And then I also just make sure that it's enabled on the debug. So I'll press F4 again, get out of that menu. Cool, now we have a good benchmark setup. So for me, I usually save this as a default and a benchmark template. And once I save this file, for example, I've now go and then this is my benchmark base that I have, for example, and I use this for all my testing scenarios from then on. That is kind of how I set everything up so I don't have to repeat any of these steps in the future, and then I have a good benchmark scenario. So let me walk you through one of the benchmarks that I wound up creating. So for this week, we were trying a whole bunch of just different staggered inserters, right, that I was showing in the very beginning. So I'm going to go and show one of them that I wound up creating here. So let's go to load game. And I'm going to go into the pulse inserters, and I'm going to grab the staggered. If you don't know, if you go to the saves directory, that's where Factorio is installed on your PC, you can create new folders, and then you can actually create you just can't create them in the main menu here, but you can go and create these subfolders and save all your stuff in there to organize things a little bit better. And that's how I usually do it. So usually give it the date, give it the name of what I'm going to be testing, and then I just create more save files. So usually when I benchmark something, one of the things that I'm looking for specifically is when I press F5 again to show the update time, I'm usually targeting something where a benchmark is going to be somewhere in the 2 milliseconds of update time. That's usually my general rule of thumb of what I'm doing. So you'll see that this one is not quite at 2 milliseconds, and that's because the first one that I wound up testing is significantly higher. So I wind up just creating enough load on a test that is going to be high enough, and then I go and copy and reproduce the same test multiple times. So what you're going to see in this particular benchmark here that I wound up creating is that we have a lot of inserters in here, all performing the same logic. Now, I painstakingly copy and pasted this, and just something that you know when you're running benchmarks, it's probably not as fun as the main game, but they're really fun to find out new things. So what is this? This is 16 columns by 92 rows for a total of 47,000 inserters, all doing the exact same thing. Why do we make them do all the exact same thing? Well, if I only tested this one design here by isolation and didn't have anything, the load on the actual system, so the actual in terms of updates per second or milliseconds, would be significantly lower. And so it would be so small that it would be just considered noise. And it's hard to do an apples to apples comparison of one versus another when you have a very small one. So one of the highest things that I would definitely recommend is that you wind up copying something multiple times so that you can get a good load on the system. And again, I'm targeting for somewhere above 2 milliseconds of update time on average. So when I go and I set this benchmark up, for example, one of the things you can also do is you can use something like Region Cloner. So you can get a selection tool from here. Once you have this open, you highlight over the area that you want to copy. In this case, the way that I've done it is I wind up saying, okay, I wanted this. And then you can shrink the area selection. And I said that I wanted 92 of these copies. So I'm going to go to the north. And I'm going to say 91 because this is the first one, plus 91 of these. And I'm just going to go ahead and press start. The reason that this is really nice is that effectively now all of these are in the same state. So it also, not only does it copy the items, but it also copies the actual state of the items on the belt. So you can see here that every single one of these inserters has 4 items in them because of the fact that everything got stopped. The only thing that I've had some issues with is copying wire settings. So I just personally just wired these up manually so that they all would work together at the same time. And I'm not going to redo this on camera here, but that's kind of the point, is you set all these up. Now you have a nice big column, and then you can go and get a selection tool again. And once you're happy with all of these, you could just go and copy these. In my case, I wound up saying that I have 15 copies to the right. So you go east, shrink the selection area, copy it. We'll wait a second for this to happen. All right, cool. So now we have a whole 47,000 inserters all set up, all ready to go, and they just need to be wired up. So that's just copy and pasting and getting that into good state. So then what I wind up doing is after I have gone and created this, so you can see the benchmarks or at least the files that I have down here, there's all these inserters nicely going. Another thing, the reason I was mainly actually doing this, just so that if you're interested in it, is I was looking at transport line times. So if I look at the gaps in transports, I was curious about how many gaps there are. So I'm going to go and turn off a couple things. I'm going to turn off the activation state just so that we can only monitor specifically the gaps in the belts. So this is what I was testing. I was curious if you were going in one direction with the belt, what is the basically update time going to be and what is going to change with it. And so that is basically the premise of the test. I'll show you one more as an example here. Yeah, so we're going to go with the 1 every 60 staggered because that also looks pretty cool. So in this one, they are enabled for 1 tick. And you can see here that the update time goes over the 2 millisecond mark. That's why this was one of the baselines that I created. And then I said this is good enough in terms of the number of inserters I'm controlling. But you can see then here the transport line times as it's going across and all the inserters as they are slowly going across for 1 tick. And then every 4 iterations, they will actually all drop altogether. So those are some benchmarks. So what I wind up doing is I go, okay, cool. I have all of those. I save these as individual files. And then I wind up going and running a benchmark. So I'll explain how I do it, but there's other ways to do this as well. So for actually running a benchmark, one of the things that I use is this tool that has been built by a developer that's working currently on this project. He's on my Discord channel. His name is Blousy is what he goes by. And he's created a really nice command line wrapper around the built-in benchmark utility that's built into Factorio. So, and which is just showing here. There's a command that you can pass in instead of starting the game. You can actually run a benchmark, and that's built by Woob. This tool is fantastic though, because it allows you to automate a lot of the things that you would normally be interested in, like generating graphs, introspecting the data, getting averages, running multiple runs at the same time. And this is an excellent tool that is being actively worked on right now. So I highly recommend you go and check this tool out. There is a GitHub page that's on there. I'm pretty active in terms of, I can't say that I've done too much. I've done like one change that I've made myself, and Blousy has done all the hard work. So really thank you to him. So something that we're actively continuing to work on. It's a tool that basically just makes your life as a benchmarking enthusiast substantially easier. So some of the commands, you're going to have to be a little bit more familiar with the command line, but it's really easy to do. So one of the prerequisites that I'm not going to explain in this video is you need to install Rust. Just go to this link here, and the video description will have it, and then you just essentially just have to install it and get Rust installed on your computer. Once you have it installed, what you can do is you can just go into PowerShell or command prompt, it doesn't really matter, and you open up a terminal. And then what you can wind up doing is all you have to do is just follow the really simple instructions here. And you wind up saying cargo install Factorio belt. And then that will go and fetch the package from crates.io and go ahead and install it for you. Once that's done, then you'll have a command that is called belt available to you wherever you are. So I'll go ahead and let this install so I get the latest update. And you can also follow along and just see if there's any new updates or any changes, that you get new features. And if you're curious, you can join my Discord as well. We post pretty regularly updates and discussions about the tool as it's being currently worked on. So the second thing that exists is I highly recommend that you go and install Visual Studio Code. That is just the editor that I use. You do not need this at all. You can just live in the terminal. I personally enjoy it because it makes my development life pretty easy. So highly recommend this tool as well. And that's what I'm going to be using for the purpose of this video today. So once you have belt installed and you have Visual Studio and Code installed, I'm going to walk you through how to quickly create a project, and then you can go ahead and organize your life a little bit around that. The next, what I've done is I've created a folder called benchmarks on my desktop. And what I've done here is I've just created 2 new files, which I'll explain in a second. We can make those in Visual Studio Code, so don't sweat it. So I've created these just to make it a little bit faster to explain. So the first thing that we're going to do is we're going to copy our save files in. You don't have to do this. You can specify the location of your saves folder, but instead I like to keep everything in one folder. So that's just how I'm going to demo it. So where are your saves stored for Factorio? So by default, they're all going to be under your username, and it's under app data, roaming, Factorio, saves. So you go to that location, and then you just find the folder where you created your save files. By default, they're just going to be one of these files here. They're all zip files, and that's what is a Factorio save file is going to look like. So for this, we had these all as pulse inserters. So I'm going to copy these files. These are my benchmark files, and I'm just going to go ahead and copy and paste them into my folder here. Great. So the next thing is I'm going to go and open up a new window in Visual Studio Code, and I'm going to go to File, Open Folder, and then I'm just going to go to this same exact path that I have here, which is just on my desktop. So I'm just going to copy and paste that in, and I'm going to go ahead and just say select folder. Cool. All right. So we have that opened up. We can go immediately to the file browser here on the side, and I'm going to open this and make this a little bit bigger, and I'm going to zoom in. So the next thing, what you're going to want to do here is I have 2 files. So I personally like creating a kind of a snapshot of what was the benchmark that I ran, and just so I can remember to copy the commands every single time. But I'm going to show just kind of how this works here. You can technically just go directly into the terminal, and you can type belt benchmark and then ticks, etc., and you can just go through all of that. I'm not going to do that just because this is easier, and this winds up being a little bit faster for me. So what are the arguments here? Well, you have to specify a folder location, and a dot represents the current folder. So you just put a dot here. That means everything that's currently in this folder. So you can specify a template pattern. So like, hey, do I want to run just in this case? I could say, hey, I only want to do the ones that say bench 1 in them. So that would be only these where I have 1 tick that I'm using. I could also specify I want to run just the bench 4 in isolation. So this is nice if you have a whole bunch of save files, you can kind of change the pattern. In my case, I want to run them all. So I'm just going to keep it like this. This is the default, so you can delete it. I keep it just so that it makes it easier for me to just remember where those arguments are. The next is going to be an output. So this is going to create a folder called results demo. And then what I'm going to want to do here as well is just for the charts and everything that's going to generate, I'm going to remove the prefix of bench because I find it irrelevant. I just want the 1 out of every 60, right? So then the next thing that I'm going to do here is I need to specify ticks and runs. So for the ticks that I'm going to do, let's say, so how do you choose how many ticks to execute it for? So in this case, I know that every 240 ticks is going to be 1 cycle in all of these particular tests. So I probably want a multiple of that, but enough so that there isn't any variation, right? Because I'd like to ultimately capture a large enough sample so that I don't necessarily miss a swing and I get kind of bad data and skew it. So what I'm going to say is like, okay, it's 240. Let's multiply that by, let's say, 20 or 30. And that means that if I miss one swing, that's 1 over 30 in terms of the result variance. So in this case, I'm pretty sure that these are going to be very different. So I'll just choose something like, let's say, 24,000 ticks. So let's go to 48,000 ticks. That way, it's just a very large number that's going to be executed for a longer period of time, and then you're going to have more variations to them. However, for this demo, I'm not going to go and do the full run because it's going to take a really long time. So I'm just going to do really simply, I'm going to do a multiple of, let's say, 960 so that we can see some nice data that comes from it. The next is the runs. So what you can say is how many runs you want to execute for each file. Do you want to run it once, twice, 3 times? So I'm going to run it 3 times just for each file. And then finally, one of the things that you can do as well, and I'll go back to the documentation here. So you can go and specify the run order. And this is really useful because sometimes you want to run the order in terms of sequentially, so one after the other. Sometimes you want to group them. That is the default one, is running them grouped. So that's this run order command. So I'm going to put this in here. And I'm going to say here for the run order, I'm going to say in this case random. So just run them in any order you want to. This is nice so that you don't encounter thermal throttling from like having one of them run effectively when, let's say, your CPU is a little bit warmer, because there's one benchmark that just takes up a lot more CPU than the next one does. So it's nice to just have like kind of random order of all of them. That's what I would normally do. Another good option is sequential. So always run one, then the second one, then the third one, fourth one, fifth one, sixth one, however you want to do it. So play around with those. Those are good. Other than that, I'm also going to export some verbose metrics. Those are really nice because they give you some really nice just charts and data that is going to get generated from these so that we can look at any of the statistics that are currently being exported from the Factorio benchmark itself. So there's a list of these that you can look up. So just refer to the GitHub documentation for it. But I'm interested in transport line update time for this. I'm interested in the control behavior and the entity update time. Cool. So I have all that set up. So what you can do, and the reason I have a PowerShell script is because then it's really easy for me to just invoke it. This is how I normally wind up just invoking it here. Like by saying /benchmark.ps1. But there's some extensions that you can install, and there's 2 that I highly recommend that you install as well if you just want to follow along and do the same thing and you don't want to ever access the terminal. So one of them is just the built-in PowerShell. You can just install this PowerShell extension, and then that allows you to basically just press here and click run, and then that will run this for you. So that's a really nice one. Another one is just using a markdown tool. So Markdown is really convenient because you can install a Markdown all-in-one, and that'll allow you to view Markdown files. So why is that? So I have a template that I have here that is going to generate for me a nice file that I can go and read. It'll tell me the number of ticks, how many runs there are, and this is the default that is on this GitHub repo here. You can go to the templates section, you can click on the results.markdown file, and you can just copy this into a file. So for me, just to explain this, I just went here, clicked new file, we can call this template, and just remember to put the template markdown extension there, and you can just go ahead and paste it. You don't have to do this, but I like to tend to customize specifically the stuff that's in here. So I find that really useful to kind of like say, okay, just fill in the date, fill in the Factorio version, the platform, those kinds of things. So that gives me some things, and then I usually wind up writing some extra stuff. So these are the things that I wind up writing down, and then you can format this however you want to. When you have set up your template, so I'm going to delete this because we already have this here, you can then go and click here to open a preview of it. This gives you a nice rendered view. Sure, nothing is showing up here yet, but it will now once we actually run the benchmark. So let's go ahead and execute it. I'm going to execute it with the terminal. You can also press this run button, but you just got to make sure that you have this in the right folder, and this doesn't always work. So I highly recommend you just type this. So if you do this, run benchmark, you're going to see it's going to give you here a progress bar, how long the benchmark has been running for. And it's also going to show effectively the run number and how many runs are left. Since there's 6 files, I've said to run this for 3 times, and for 960 ticks, it's going to wait until the first one's done, and then it'll give you a really nice estimated, or an ETA, of when you're going to be done with it. So in about 5 minutes, we should be done with this benchmark, and then I'll show all the files that are going to come out. One important pro tip, do not delete this folder. Please keep this folder around until the save is done, or the benchmark is done, because this is where it's going to output all the results. So once this is done, I'll be back and we'll explain the results of the benchmark. While this benchmark is running, I just want to explain what's going on here in the background. So what's going on in the background is this tool is calling Factorio and is running a headless version of it, so no user interface. And it is constantly starting it, stopping it, loading the save files that are in this folder, and then executing for the number of ticks, recording something as an output, and Belt is currently capturing that. So that's what's actually going on behind the scenes. Now, another thing that I would highly recommend that you do too is don't record videos, don't do all these extra things that I'm doing in the background, and really try to minimize the number of applications that are running while the benchmark is going to eliminate noise that is happening in the background. So this particular benchmark, take with a grain of salt. I normally step away from my computer, just let the benchmark run, and then I'll come back after the ETA is done. And that's normally what I wind up doing. So I highly recommend you do that as well. Just extra information while we're waiting for the benchmark to finish. So the benchmark just finished. I had to rerun the benchmark again because I had put in the wrong path to the result. So that's I've corrected that mistake, and now we have run it again, and all the benchmarks completed. Yay! We had 18 runs. So this dumped everything into the results demo folder like I asked it to. So there's two files that we're gonna look at first. First, there's a result.csv file. So I use an extension that is called edit CSV, so that I can just quickly and easily just go and press this little edit CSV button, and I never have to leave VS Code to look at anything. So this will tell you the name that was run, the run index, and the execution time. That's the total time in milliseconds it took to run the file. Then the next one is you have average millisecond update time, so that's per tick, how long does it take to compute it, what was the minimum, and what was the maximum. What you're looking for here is the best benchmark is going to be the one that has the lowest average millisecond time. This will also compute the effective UPS, so that means like the game itself has 60 updates per second, right? So if you're running at 2 milliseconds, you're going to be significantly higher than the maximum it would take to get to a single tick going below basically 60 UPS, right? So either way, this will show you there's basically the overall times and how long that took. And then it also computes a percentage improvement from the worst, so whichever one was the worst is going to be scored here. And it also tells you the number of ticks that were run, so that's 960, Factorio version, and the platform. I'm running this on Windows, so you can also run this on Linux. I'm just giving a tutorial for Windows today though. So cool, result is done. The next one is this markdown file. You remember this template that I created, right? Well, now it's populated all these wonderful values for us, which is great. It tells you the date, when this was run, Factorio version, and the platform it was executed on. You can go ahead and click the preview button here. And then that gives you a nice, really nice readable version that you can share on a site like GitHub, and then anyone can access it. That's how I typically use it. So this will give you all those same stats that we saw in the CSV, but it aggregates them. So it takes the average of all those runs. And so then it winds up saying here, what was the max from all the runs, the minimum, and the average that you wind up seeing, and what's the percent difference from the worst. So you can see here that when I was going and computing this, what was interesting was that there was a variance here, and this is actually going to showcase beautifully why you should run the benchmark for longer. So it shows here that like, okay, if we staggered it, it was worse performance than when we just had it for every 240. And we'll talk through that a little bit. So this gives you the UPS outline. This tells you a box and whisker chart of the distribution of benchmark runs, because you're going to have noise. Sometimes a benchmark runs faster than another one. So, and because Factorio is deterministic, that variance shouldn't actually really exist, but it will because I'm recording a video or I'm doing who knows what in the background. I have OBS pulled up. All those things are going to impact the benchmarks run. So running it for longer and for multiple benchmarks is going to give you a better actual accurate representation of what it would look like in a real game. Once these things get really close in terms of it, that's when you have to run the benchmark for a lot longer to really see a difference. So what's nice about this though too is I can go now, and because I chose the verbose option, I can look into a lot more just wonderful graphics that have been generated from all of those runs. So the one that I'm really interested in is if we go back to this example and we open up the preview, I'd like to look at the transport line time from the best performer here, which was the 4 out of every 240, and the worst performer so that I can look at them. However, what I'm really interested in is why was this one better than this one? And because in my mind, I would expect the staggered to perform better. So let's go and look at that. So let's go to the bench for every 240. And then I'm also going to open up to the side. I would like to know the for every 240 and then just the transport line time for that. So there it is. Okay. So I'll go ahead and open these side by side. I close this. You can double click on the middle here to center them so that you can compare them. So what's interesting here is you can see kind of what I'm saying with this is that in this period here, we had exactly a spike where we started right when the inserters all swung. So this one happens to exactly stagger at the beginning. So you're seeing this nice graph that fell almost perfectly within the 960 and then drops off. However, over here, it's kind of offset. So you're missing this tail edge, right, of transport line time and just the inserters being active. So that means that in general, especially if we go and look at the whole update time of those two benchmarks, and by the way, there's two versions of this. There's one that shows you all of them here. So I'll open this up. And there's also a version that's nice that takes the minimum per tick and displays that. And that's this one here. This is nice because since Factorio is deterministic, whatever is the best value during a tick should be actually what the real value is. That means you didn't have any noise from your computer. You can see just how much just these random noise spikes that happen because of other background processes that are happening or whatever, because again, this is not a perfect benchmark. I'm recording a video while I'm doing it. So you can see just kind of when you look at these two values, you can see this is more representative. So by running it multiple times, you're going to get a little bit more of an accurate view here into the data that's there. So you can see some things that are really interesting once you start looking into this. In this one, all the inserters swing at the same time, so it causes a huge spike in terms of the update time, and then it drops down to nothing. And so you can see those periods where it happened to happen. So, and then you can see here, this is a lot more normalized because they are being staggered. So each of those inserters are staggered over the full 240 ticks, and you have small micro spikes like this. This I know is going to distribute the results better. However, what you're seeing from this is that because you didn't have enough runs, that average over time, this huge spike that exists is going to basically make it so that it on average is going to be lower here, and you're not going to have enough data to actually represent what happened. And you're also missing this tail end where things went off. So in here, and when we saw the transport line time, it started exactly in the beginning, and this one was offset a little bit. So that kind of gives you a variation for why like you should probably not run these in such a short succession. So I'm going to go ahead and open this up in the actual save file, and this is from my GitHub repo and how I run everything. So when I ran this file here, I wound up running it for 14,400 ticks. So the reason I chose that number was just to have a larger variance. So when I look at those exact same ones again, you're going to see I have a lot more data in here in terms of the transport line time that was there. And if I look at now the transport line time, if I look at the basically the staggered version, if I open that one up and we look at both of these here, you're going to see that now I have a lot more of a sample. And so even though these were slightly offset in the beginning and they didn't exactly start in the same sequence, I have now enough data to actually draw a conclusion, and I have enough larger spikes for it to start not just being an outlier, but being more of a majority. And you can see the difference in transport line time. So now when I look at the results from the actual run that I have, and this is on my GitHub page, and so you can always refer back to this, we can see that this was kind of what I was expecting, is that now this result is a lot closer, right? So when we had run it previously here, and so this is showing that this is reproducible, the overall net benefit here, and let me close this out and open it up over here on the left and on the right and show both of them. So you'll see here that the overall percent improvement starts to actually become, or at least the effective UPS was higher compared to the last one because it had less noise running in the background. And you can also see on the distribution of values, these were a lot closer in terms of the runs that we did, because here we executed this for 6 runs and 14,400 ticks, and I didn't have anything running in the background. So really important to not run at other things while they're actually being executed. So then you can also see the percent differences wind up showing up a little bit more. And you can see how much closer these two are. And so this actually is what I would expect to see in real life. And that's why you should run benchmarks for longer, so that you get a better perspective on, and you eliminate the noise that can come from just one starting a little bit later than the other one. So running them for longer gives you a better data, and then you can see that these are closer. And that also makes sense if you think about it, and this is also really critical to benchmarking, is you have to kind of check if the theory matches what you're expecting. So because and this is general good practice for testing in general, is to validate the tests and make sure that you have enough samples to actually prove what your result is. So in this case, I expected the one tick to do bad, and that is very clearly shown by the difference in percent differences here. However, these two make sense that over time they're going to average out, because the game is, instead of processing them all in one tick or for 4 ticks, this is now spreading it over for 4 ticks every 8 ticks. So that it makes sense that eventually, if the longer and longer you run, these two should be equal in terms of their UPS, right? The difference is, like that example that we showed, this is going to normalize that distribution so that now when you're looking at it and you're looking at the staggered transport line updates per tick, this is now going to spread the updates over time. So that means that this doesn't make a UPS improvement for you in the long run. What this would really be doing is this is going to make it so that you have a smoother UPS over time. You don't have large spikes. So that is just an optimization you can make, and that also is proven by the results. So that was a benchmark that I did. That's kind of how I run benchmarks. Just to talk through it a little bit more, I have a lot of different things, a lot of benchmarks that I run. So I keep one place where I have my result template, and then I have lots and lots of runs. And so I will have, for all the videos that I wind up creating, I create different folders. I put everything in there. I personally just always put this here so that I can copy and paste it when I go to the next one. And then I also optionally run this in a place where I explicitly specify the mods that I run, so that I don't have to go and save the files explicitly with these mods. I just have to make sure that when I run it, I have the mod selected that I actually need in order to run the particular save file. So there's more options that you can do by going to, and you can read the documentation that is on the GitHub page that's linked in the video description below for more things if you want to customize it further. But for the basics and how I wind up running it, that's effectively what this video was about. So if you can't tell, I'm a huge fan of this tool. We are actively continuing to develop it. So there's updates that are coming out all the time. Please go and give it a star on GitHub. Velocity definitely deserves it. He's created an absolutely fantastic tool here. Just in the recording of this video, he's already gone and added the ability to export all the individual verbose metrics as a CSV, so you can chop and slice the data however you want to. So actively being worked on. It's an amazing tool. Definitely want to spotlight it in this as we continue to develop amazing new tools as a community. With that, thank you very much for watching. My name is Bucknasty. Have a great day.